Hello everyone, this is Amritpal Singh. Welcome to the next video. Guys, in this video, I'll be discussing that how we can make use of ANN for customer churn prediction, right? So this is the data set we're gonna use and we're gonna implement this in RStudio today. So you can see this is the data set. We have some parameters available like customer name, surname, customer ID, surname, credit score and all. Based upon this, we have to predict whether the customer will exit the bank or not, right? So based upon these features, in these independent variables, we have to go with this dependent variable exited, that whether the customer will leave the bank or not, right? This is the problem statement for today's video. So this is we're gonna implement in RStudio. So I've already have opened up the RStudio for it. All right, so let's get started. First of all, we need to first of all, I'll be showing you the steps for this video. We're gonna use these steps for this today's video. First, we have to import dataset. The dataset is available in my D drive. Second is we have to encode the categorical variables as a factors. Third, we need to split dataset into training and testing set, then followed by the feature scaling method, followed by the fitting ANN to the training set, and then predicting the test set results, then finally making our confusion matrix, and then we have to shut down the package. So let's see how we can implement these steps, right? The first step is to import dataset. So dataset is available in my D drive, as I already said. So I'm gonna use maybe some variable, let's suppose churn equal to read.csv, because the CSV file which I have shown you, and it's available in my D drive. So I have to go into D drive. So D, then we have to specify this file name. The file name is churn modeling. So we have to use churn underscore modeling. This is the name of the file. It's a CSV file. So, and we have to use one more thing here that we used to do in other videos, header equal to true. All right, this is already done, I guess. Let's see. Yes, we got the data set here, right? It's all good. Okay, next step is to we have to now decide which columns we have to keep, which column we have to leave. Okay, so we have to decide that which one we're gonna have the impact in our problem statement. So first of all, row number as such will not have any impact on our data set, so on this problem statement. So we'll have to leave the first index number. Second one, the customer ID, it's similar as the row number, because just a kind of identification. It doesn't have any impact for our final result. We also leave that for first. Then we have a surname, again surname having no impact again, but afterwards the credit score. Yes, the credit score is important. The customer who's having lesser credit score will it's likely to leave. The customer with the higher credit score will likely to retain or stay. Then geography, yeah, we have to also look for whether it's a geographically related problem or not. So it is also playing it also be playing the role. Followed by the gender, we have to keep whether we can do some analysis later on whether the female or the male who is exiting more. So we also require this information. Then again, age group is important. Then we have a tenure, means how long this customer is there in the bank. Like obviously the tenure, if customer is having more tenure, obviously it's likely to stay in the bank. Balance, obviously if your customer is having the balance in the bank, he or she is going to retain like stay in the bank. Then we have a number of products the customer has purchased from the bank. Obviously if it's more products, obviously he or she is likely to stay. Then has a credit card, obviously credit card also play an important role. And then we are having is active member, obviously the customer who is active member will likely to stay. Then last is estimated salary, obviously estimated salary will be playing important role in this. So it means right from the credit score till this M, all will be playing important role in our estimation. So it means these are the independent variables we have to keep in our records. So let's see, let's do the subsetting now. So let's now include all these variables. So I'll be now you doing some little subsetting with the brackets, square brackets. So we require right from 4 till 14. Okay, so what it means, so I'm just starting from 4. This is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so these 14, these data we require in our data set. So rest we are leaving the first 3. All right, now if I again run this, you can see a data set is starting from credit score till the exited. So it means we have done the first step, that we have now get rid of the unwanted columns. Afterwards we have to now encode the categorical variables as factors. So we are having some data in which it is having some Like we have to convert this geography and gender data into the some we have to map those to some numbers. So we have to encode this the categorical variables as factors. So let's do it. So we have churn. Okay, then inside the churn we are having first is geography. So geography, yeah, equal to, we have to convert into as dot numeric. Okay, and then obviously first of all we have to convert into a factor. Factor is a data set, sorry, the data set is name is churn. Inside the churn we are having geography. So yes, geography, then we are having comma levels equal to the levels are, we know that in this we are having three unique entries. This three unique entries are, first we are having France. Okay, France. Second we are having is Spain, and third we are having is we know it's a Germany. So we have now written all the unique entries in it. So you can see France, Germany, and all. Okay, done, comma. Afterwards we have to also specify the labels. Means we have to now specify that how this France, Spain, Germany will be mapped. So we can specify with the labels. So I'm doing it with the 1, 2, 3. So means France will be mapped with 1, the Spain will be mapped with 2, and the Germany will be mapped with the 3. All right. So 1, 2, 3. All right. Okay. Done. So it is done. Okay. And in the same way we have to do it for the gender as well. So it will be same. So what I'm doing is for gender. So gender. All right. As dot numeric factor. Then we have the here we have to also write the gender, and then levels will be female and male. So instead of France we have female, and then we have a male. So we have just a two entries in it. So we have instead of this we are using now male and female, and labels will be 1, 2. All right, done. So let's see, check out the data again, how it looked like after undergoing all the changes. You can see now the geography has been changed to 1, 2, 3, and gender also has been changed to 1, 2. All right, and so it means we have done the second step as well. We have now encoded the categorical variables as factors, and we have turned into a numeric with the as dot numeric. Afterwards we need to split the data set into training set and testing set. Let's do that. And we already have in my previous videos of R, in which I've already have explained that what's a package we have to use. We have to use the same package. It is nothing but the library. Package name is CA tools. So we have to just load that CA tools. All right, so done. And afterwards we have to set the seed value, the random value, and we have to, I'm just again setting it as 1, 2, 3. Done. Now we have to do it with the sample dot split. We have to divide the data into training and testing part. So I'm going with the sample dot split, and in this case we are using churn, and we are using the exited, the last column exited, and we have to specify the split ratio. Means how you want to divide. I'm going with the 80% ratio. Means actually we are having total 1000 records in this data set, so 8000 should go to training and 2000 should go to the testing. So here we are specifying as 0.8, means 80% is my split ratio. So now my training set, okay, I'm going to have my training set, and this training set will have the data subset, and then we can specify churn. Okay, then this we can specify split equal to true. Okay, this will include the 8000 data, and the same way we can do it for testing set as well, the training set, and then we have we are having testing set, and again we are going to have here we are instead of true it will be false. Okay, so done. So we have now converted the data into two parts, the training and testing part. It is done. So we have training set and testing set. We can also check one by one. Testing set is having this much of data. All right, and then in the same way we can specify the training set, and training set also will be having some data. It means we have done. So we have done till these steps. Next step is to feature scale. Means we have to keep all the data into on one scale, right? There are some values like balance, okay, estimated salary are having higher values. We have to keep it in a one scale only. So we have to do the feature scaling. It's important. So for that we have to we have to now, because this training set also include one dependent variable, which is my exited column. We have to get rid of that. We don't want this. So because it's available in my index number, let's see the index number for it. So the index number for this is, you can, because we have data down start from credit score, so it means 1 2 3 4 5 6 7 8 9 10 11. It means it's a 11th column, 11th index number. So we have to write minus 11. Okay, minus 11. Then we have to use scale function, and for the scale function we can specify now training set, and then we can specify minus 11. The reason of using minus 11, because we don't want the dependent variable, so that's why we are doing it. So in the same way we can do this for testing set as well. So testing set, and we can also write it here, testing set. Okay, we are done. Okay, this step is also done. Testing set done. Okay, afterwards now we have to fit ANN to the training set. For this we're going to use the important package. It's called H2O. I've already have installed this package. In case if you don't have, you have to install this package H2O. We have to load this library H2O. Okay, it's important package for this tutorial. Okay, now afterwards we have to now initialize this package. Okay, it can be initialized with the H2O. Okay, H2O dot init for initialization. Okay, and then we have to use we need to use this parameter n threads equal to -1 as specified in this -1. Okay, done. It will take some time, and it will be connecting to, it will let us connect to the S2O instance for our further calculations. All right, this is an important step. Okay, now we have done. We have now inside this node, in this we have connected to this, because the thing is that learning thing is very resource we can say we require a lot of resources for running our deep learning algorithm. So what we are doing it, we are just connecting to this S2O cluster, so that it is let us run our things easily, because it will be a quite resource intensive task. So that's why we have to include. So you can see now we have connected to this one node, and it's have a total memory 3.48 GB. Total cores are 12. Obviously more the number of cores, more it will be giving us like resources to run our algorithm. So it's important to connect to this. So we are now connected. Afterwards now we need to deploy a model. Okay, for it I'm just using maybe model equal to H2O dot deep learning. Okay, deep learning, and inside this we have to first specify the first variable I'm to take it into consideration is this parameter y, and y will be the dependent variable. It is exited. We all know it is exited is a dependent variable. Done. Afterwards we have to specify the training frame. The training frame, obviously it will be because we are going to fit ANN to training set, so training set is the training frame. So second parameter I'm gonna use is training frame. So training frame will be my training set. All right, but the training set, because currently this training set is a default data frame of R, we have to convert this into a S2O data frame, and for that we have to use as.h2o. Okay, I'm again repeating, this training set that we are having is a simple data frame, but this simple data frame will not work. We have to convert to S2O data frame, so we have to use this one, as.h2o training set. Done. Afterwards we have to use activation function. I've already have explained in my previous video of neural networks that what are activation functions, and we're going to use one of the very popular activation function, which is called rectifier. We are having a lot of activation functions available, sigmoid and all. Okay, tangent. So but we're going to use the very popular one, rectifier. Afterwards we have to specify how many hidden layers we want. Okay, how many hidden layers we want. Okay, actually in this case there's no specific formula, although, but I can give you a little hint here. Because we are having total 11 independent variables. Okay, so 10 independent variables, 10 input nodes and 1 output node. Okay, which is correspond to the 1 dependent variable. So 10 plus 1, it is 11. So it's the average. 10 plus 1, 11 divided by 2, it is 5.5. So we are taking round off figure, which is 6, and we are just considering 2 hidden layers. Okay, so for that, how we can specify? We can specify with this equal to C, because we know this C function used in R for the vector. So it is 6,6. What it means? 6 neurons in one hidden layer, 6 neurons in second hidden layer. So we are using 6 neurons per one hidden layer. It means we have 2 hidden layers, and total we have 12 neurons. All right, done. Afterwards we are having another parameter, which is called epochs. Epochs means iterations. Okay, so we are taking it as 100. Again, you can customize this. Afterwards, we are having trained samples. Again, another last parameter we're going to use, train samples per iteration. What it means? So train samples means number of observation after which you update the weights. Okay, we already discussed this basics in our previous videos, what is weights and all. So it's the number of observation after which you update the weight. It's like a auto tuning the ANN. So for that we are using the default parameter, default value, which is -2. Okay, and we are done. So this is the like very important statement, which is now fitting the NN2 training set. So in this case, we have just used this y equal, it is the dependent variable, training frame is the training set, because it did not take the default data frame, so you have to convert to S2O data frame. That's why we're using as.s2o. Activation function is rectifier. The hidden layers means we have two hidden layers of 6 neurons each. Epochs means number of iterations, and then train samples per iterations, which I already told you, it is number of observation after which you update the weight, which is -2 as default value. All right, we're done. Now step is to predict the test results. So for that we're using some kind of a test prediction, something like we can define equal to h2o dot predict. Okay, h2o dot predict, and the model name is model, we know. Okay, comma, and afterwards we can specify new data. New data will be, obviously it will be my testing. Again, as in the previous step, we have to convert to the training set into a S2O training S2O data frame. In the same, we have to convert into S2O data frame. So for that we have to use as.h2o. Okay, done. And we can specify the testing set. Okay, we can specify the testing set here. So testing set, and we have to just like ignore the last one, -11, right? And we are done. So we have we just now in the process of predicting the test results. Afterwards, now this is done. Now we have to do what? We have to now convert this into a Boolean values. All right, this test prediction, how we can do that? So this test prediction, again we can just specify here, very simple thing. It is, we're just specifying the threshold value here. Okay, it is test prediction. Okay, test prediction, and then we can specify 0.5. What it means, that if we are having value probability, what is getting what the value we are getting, if it's more than 0.5, it will be converted into true, because we are just going with the boolean value. If it's less than 0.5, it will be false. Okay, that's what we are doing here. Okay, it's done. Afterwards, because it's still a S2O data, the results in the form of S2O only, we have to convert that data back to our normal vector, so that we can use it for my creating the confusion matrix at the end. Okay, so for that what we can do is, we can now again do the same. Test prediction equal to, we have to now use as.vector to convert this S2O data frame back to vector, and here we can specify test prediction. Done. All right. So now let's see the answer, what we got, test prediction. So we have got this. This is the data answer we got. Okay. Okay. Let's now try to compare this with the original data. Okay. So with the testing results. This is the testing set. Okay. So now just check out, we are having 0, 0, 1. Means 0 means stay, stayed, leave, 0, 0, 0, 1. Okay, this is the result we got. And what we have in testing, just see 0, 0, 1, 0, 0, 1. Okay, it means it's quite matching. Just see 0, 0, 1, 0, 0, 0, 1. Okay, this is the first, I can say 3, 4, 5, 6, 7. First 7 results are 0, 0, 1, 0, 0, 1. Here also we are having 0, 0, 1, 0, 0, 1. It means it's quite encouraging results. Okay. Now let's create the confusion matrix to check out how much we got the right and how much we got the wrong. Okay. So we are going to make a confusion matrix. Confusion matrix equal to, we are going to use the table function, table, and then we can use again testing set. Okay. And we can specify, we just have to include 11, this last data, exit data only, comma, test prediction. Test prediction. Done. Let's see the answer. Confusion matrix. Confusion confusion. Okay, this is what we got. Okay, it means we got this much of right, means 0, 1, 5, 3, 4 and 184. These are the right answers. Let's see how much we got at right. 1, 5, 3, 4 plus 184, total we are having 2000. It means we got almost 86% correct. Okay, we got this. It means the result is almost very good, encouraging results we got. At the last step, we have to now shut down our H2O instance. Okay, how we can do it? H2O dot shutdown, the last one, and we are done with this shutdown. Okay, just write capital Y. So we are done. So this ends the today's video. I hope you must have understood today's whole concept, that how we can make use of ANN for the customer churn prediction, right? Thanks for watching, guys. See you next video.